So, what have I been doing for the last few days during lockdown? Well, it's not insight work. I've been working on something simply for my own amusement, and of course, it involves pics, etc. And it also involves a hacked OBD2 CNC. So, there's the hacked OBD2 CNC. This is a totally minimal install here. So it has no lines for K and H line, etc., etc., because it's not for connection to the car in any way. It's to control another type of device, which I shall show you in a moment. And this is basically a living room talking piece. It's based on a very old piece of computer programming, which we'll get to in a minute. So basically, the only differences really to this one are it hasn't got most of the components. It's got the switch and the LED, etc., and the display, but none of that's programmed yet to do anything, but it will be soon. And it has a different PIC. It has a 18F26K80, and that is a pin-for-pin replacement for the other PICs that we use in this device, and that is capable of working at 64 megahertz using the internal oscillator, and I need that super speed for the device I'm controlling with it. This one's actually been configured to run on 5 volts, and what I'm doing is I'm using it to control a string of LEDs using one of the WS2812B LED matrices, and they are basically series connected LEDs which have a data bus, a PWM data bus, which requires quite tight and fast timing, and basically you can send a message into one end of the bus and it will go through all 256 LEDs, and then we'll do whatever you want to do. So you can have pretty patterns. These are RGB LEDs, and what I've done with it for now is I am programming it for the Conway Game of Life, but these are multicoloured LEDs. You can see that it stopped working there because that is a stable life now, so this one stopped again. So at the moment it's very crude, and this is purely to prove that I can drive this LED matrix. This is 256 LEDs here, and you can see this particular it randomly seeds the LEDs every sort of 200 evolutions, and then it goes away and processes it, and you can see it's quite interesting to see how the things develop and move around. I haven't seen any gliders yet, apart from one I introduced manually. So if you know anything about Conway's Game of Life, then this concept will be familiar. It's a pretty familiar thing for all programmers. So the interesting thing really is basically we've got an OBD2 CNC driving this Game of Life module, and the idea is to obviously make this quite sophisticated. Options to select different patterns, different colours, because these are RGB LEDs. Obviously it's useful because it's got the switch and the display, so we can have a number of cells alive, and we can have the number of evolutions that it's gone through, etc., etc. So the sky's the limit really with this once we get going. But I've only just finished the sort of proof of concept code, which is to get it actually doing something and displaying on the LED. I haven't got any colour code in yet or anything, but you get the gist of it. So it's quite an interesting little project, and it's taken me like 2 days solid work to get to this point, and now I need to start tidying it up and getting it to look a little bit more sophisticated. Then I'm probably going to build it into a picture frame and have it controllable, and you can select the colours and blah blah blah, and we'll go from there. So at the moment I'm seeding like a random number generator using noise from an ADC pin. So you get random noise in your house, and it picks up this noise and uses that then as a seed. So hopefully you shouldn't get similar patterns occurring all the time, and then it just randomly seeds 50% of the cells depending on the number that's generated. And you can see it's working quite quickly. I've actually got quite a lot of delays and loops in here to slow it down, because it is actually really quite capable of driving this very fast. Certainly 20 or 30 frames a second I would think would be fairly easy. Revolutions or generations a second, probably even faster than that, because the PIC is running flat out at 64 meg. So that makes the code to drive the pixels is very fast, and then it leaves a lot of speed left for the other functions are evaluating the life grid that you can see there. So yeah, proof of concept. So I was thinking about actually getting 4 of these panels. I have got another panel, and putting 4 to make a 32 by 32 grid. These are 16 by 16 panels. These ones here, as I say, based on the WS2812B RGB multicolour LEDs, and these are all connected in series, and you can pass data in at one end and it goes right through and comes out the other. So I could then cascade this to another panel if I wanted to, but obviously the software then becomes a bit more complicated and the refresh rate would go down. So for now, for this proof of concept, I'm just going to use the 16 by 16 panel, which is 256 LEDs, which is a nice number, and you can see it's really working quite nicely there. I'm not quite sure I've got the live code exactly right, but it's probably not far away, because it looks very familiar to other life programs I've seen running in the past. So we'll just keep fiddling around with it. Now I need some things on the display that are of interest, how many cells there are, etc., etc., as I've been saying. And perhaps get it to beep every time it reaches a steady state, so it resets or something, you know, just to add functionality to it. So that's what I'm doing, OBDIIC&C, proving its worth again, and now driving one of these fancy LED displays. You could do scrolling text and all that other stuff if you wanted on these fancy displays, but I'm certainly not getting into that. I just like the game of life because it's an interesting concept made popular in computers over the years. So that's where we are. That's what I've been doing. Well, that's an interesting one. That's reached a sort of like steady state there, and it'll reset itself shortly.